can open it. People don't have, just go near to these people. Okay, so we said in engineering we are trying to provide solutions, using the knowledge to provide solutions. When we are trying to provide solutions, we have to look at specific questions. Okay, so whatever you are providing to your client or to your boss, okay, before you give it to them, you have to check it. Okay, so these are the things which we should check for. First of all, will it work in real life? Okay, the second one is, what are the assumptions I am making? Okay, then future risks, and then the impact on people and environment. Okay, so whenever you design something, you are doing something for your client or for your boss as an engineer, these questions should be in your mind. The first thing is, what you are doing, is it practical? Can it be done practically? Okay, so you are telling the client that I will build you or I can design a building that can take the load of earthquake and wind and whatever you have. Okay, but to build that building, you need a material which is not available in the country. Okay, so your solution is good, it will solve many problems, but it's not practical, it's not real for him. Okay, because the things which he needs are not available. Okay, another example, you take the same example. Okay, the material is available, but it will increase the building cost by 200%. Okay, so the client has a specific budget, right? Nobody has unlimited amount of money. So again, the project for the client is not real because you are asking too much money. He cannot afford it. Okay. Another example which happens many times in road projects is a space. They are saying, okay, this intersection, you have seen there are many intersection signals and roundabouts which have problems, right? Some of them have many accidents, some of them have like long queues for 2-3 hours. Okay, you get stuck on them, right? Okay, so you are thinking, why don't they do something about it? Okay, and you can say, oh, I can think of a solution to solve this problem. Even I'm not even an engineer, like till yet. You will, inshallah, right? Nobody is saying inshallah. So, but you are thinking that, for this location, even I can provide, I can think of a solution. Why the government is not doing it? Okay, they know the situation, they know the problems. Okay, when an accident happens, the report goes to them, right? When there is a traffic jam, the police comes and they try to manage the traffic. They know the problem, right? So why are they not doing anything to solve it? Because in many cases there are space constraints. To build a bridge, maybe they want to remove the intersection, build a bridge, but they don't have the space. Okay, the bridge needs access space. It's not there. Okay, or they want to build something, they need to do excavation and put the foundation for the bridge or something, but they are underground utilities and you cannot disturb them. Okay, there's an underground old pipeline or something. Okay, and you cannot disturb it. Okay, so the solution looks logical to everybody, but it's not real. Get the meaning of real now? Okay, real means something which the client can do with all the constraints and all the limits he has. The limit can be of time, it can be of technology, it can be of money, it can be of space, anything. Okay, so if your design does not fulfill any of these requirements, in the end the project is not real. For him it is not real. For the client it is not real. Got it? Clear? So it's not only about giving the right solution, it is giving about solution which is practical. Okay. Then when you are making this solution, we talked about this point last time as well, you make some assumptions. Okay. You assume things which you don't have exact data for. Okay. So can we assume anything? Let me, okay, I don't have the data for concrete which is mixed with some new material. Okay, so I'm using some new type of cement, and with that cement I don't have the unit weight of concrete. Right? So can I assume anything? No? You can assume something similar, right? Okay, so but these assumptions must be known and listed down. This is the point here. Okay, I'm making my assumptions, obviously. I'm making it because I don't have the data. Okay, but you have to separate the two things. Okay, so I calculated the strength of concrete because I have an equation for that. Okay, so this is not an assumption, right? Calculating strength of concrete is not an assumption. Okay, but to calculate it, I use the density of concrete, which was an assumption. Okay, or I use the hardening time of cement, which was an assumption. I don't know the exact hardening time of this new cement, so this was an assumption. So in my report, I am showing both, right? I am showing the strength and I am showing the hardening time, both of them. Okay, but I have to mention them separately. Okay, so the client should know that this was an assumption and this was the real one. Clear? Okay, in all projects some things are assumed, especially in construction projects, because you cannot know everything all the time. Okay, so there are some things which are assumed and some things which are real. Either you observe them or you have calculated them yourselves first hand. Okay, so you need to separate between them. Okay, you don't need to mix them. Okay, and you have to list them down. You need to list down your assumptions and you have to keep them separate from the actual data or the real calculations. Clear? Okay. Then the risks, the future unforeseen events which can affect your project, very heavy rainfall, any earthquake, what else? Sandstorm, okay, high temperatures, an accident, okay, war. So all these things, they are potential risks, right? So you list them down and you will also see if one of these things happen, what will I do? Clear? Okay? Everybody? So for example, you assume that my project will finish from this month to this month, and normally during these months there is no rain in Bali. Right? There are very specific months in which they have rain, right? Okay, same thing in Pakistan as well. There are specific months where you can expect rains. Outside those months, nothing, zero. Okay, we have something similar, right? Okay, but nobody can know for sure. It can happen. I don't know. It doesn't happen. It may not have happened for the last 10 years. But still, it can happen now. Right? So when it does happen, and it will affect my project, what should I do? Okay, so for example, you are doing concreting, let's say. Okay, so if there is very heavy rain and you are doing concreting in open, they don't usually do it. Because you will have water coming from the top and you cannot stop it. Okay, so it will affect your mix. Okay, concrete is made of what? Aggregate, cement, sand, put all the water you have. It's a specific ratio, right? If this ratio disturbs, it will affect concrete, will affect its strength and everything. Okay? So that's why heavy rains, they don't do concrete. But now it is happening, so what should we do? Should we just close the project and go home? No, they have some measures. What can they do? Okay? Yeah, something. Okay? So the point was, identify the risks, something which is unlikely but it can happen and it will affect your project. And then you prepare your plan. If this happens, what will I do? Okay, so not just identifying the risk is not enough. If it happens, you need a plan, or you should have a plan of what you will do. Okay, then whatever you are doing, you have to calculate the impact of that decision, that design, that product on people as well as environment. Okay, so for example, it's a government requirement. If you go to the government and you say that I will build a new mall, okay, or a multi-story plaza somewhere. Okay, so before they give you the approval, they will ask you to do a traffic impact study, and it's done even for smaller projects as well. So it's not. I'm not only talking about 100-story malls. Okay, even for the smaller project, they say, okay, you do a small study, but still you have to do the study. Okay, so before you get the approval, you have to tell the government that this is the effect my building will have on the traffic. Okay, and in some cases, the government will work with you to reduce the impact. So you will say, okay, because of my new plaza, new mall, we will have 2,000 vehicles every day on the roads because of this project. So there are already vehicles on the road, and there will be 2,000 more. Okay, so it will change traffic, right? It will change the traffic on the road. So the government now will work with you to see how we can reduce the impact. Maybe these 2,000 vehicles will cause a new traffic jam in the evening. So the evening was free, but because of your mall, it will be busy in the evening as well. Okay, so the government will work with you and they will, propose something to reduce the impact on traffic. Okay, clear now? Okay, you have big projects like power plants, okay, or oil pipelines, or oil refineries, or these things. Okay, so for these type of projects, they do environmental impact assessment as well. You will not get the approval until you do the environmental impact assessment. So you are not talking only about traffic, you are talking about environment in general, especially for industrial projects. Okay, so something like Alba or Babco. Okay, so their refinery is not only generating traffic, it is also doing chemical reactions, right? Okay, and there is heat exchange and so on. Okay, so they do the environmental impact assessment. And what will be the impact of this project on the environment? And again, the same question: if this is the impact, what you will do with it? Okay, how will you try to minimize that? Got it? Okay. So as an engineer, you have to keep these things in mind, and when you are providing the solution. So the courses which you are taking, which are maths, physics, and some of the courses have labs in them. Okay, some of the courses require you to design. Okay, so through these courses, you are trying to build your skills for analysis. Okay, how you should analyze things, how we can calculate different things, and also how we can take decisions about our designs, okay, about our actions. Okay, so these courses are designed to help you make your decisions. First of all, do the analysis and then make your decisions. So I asked you in the last lecture as well, when you think about a course, a new assignment, a new exam, don't think what I can do in the exam, the time, the duration of the exam, the day, how many slides and how many notes. Not only about that. Okay, you should think, do I know the topic? Like, did I understand the topic for which I am giving the exam? Okay, do I understand this assignment which I am submitting to the instructor? Okay, when I finish the project, my term project, did I learn something from it? Clear? If you are not doing that, then your assignments and progress and exams are you are just going in the record. You will get the grades in the end. Okay, high or low, but in the end, B is a pass and C is a pass and A is a pass. It doesn't matter. Okay. Sometimes the person who has the A grade doesn't have the understanding. The person who has the B grade has the understanding. Okay. So the person who has the B grade, because of his understanding, he can be more successful in the field. Okay. So the courses are not just or these activities are not just there to give you grades. They are there to increase and check your understanding. Okay. So if you are not learning, if you are not increasing your understanding, then your grades are useless. Got it? Okay. So when you have when you understand things, okay, you become more confident. There is something when you memorize something. So I have like I know a friend when we were in undergraduate, he used to be in my group, and his memory was very sharp. Again, he can read the whole newspaper and memorize it, and he used to do it. And he used to come in the class and bore us with it. Today I read this. So for 15 minutes he will be talking about the news for today. Okay. So his memory was very sharp. So when it came to presentation, obviously you go, because you can memorize, right? Okay. So he was the first guy and the last guy in the presentation. Okay. But he will not let anybody ask questions during the presentation. Because if you stop him, it's gone. I should start again. Okay. But if somebody knows what they are talking about, it doesn't matter. Okay. So that guy, he looks confident, but he is not confident. Okay. He looks confident because he is speaking very fluently. But if you stop him and ask any questions, he cannot answer. He will not stop first of all. Okay. I remember in one of the presentations, as soon as he finished the presentation, he did not even wait for somebody to ask questions. He said, if you want to ask question, ask him, and he ran away. All of us were looking what happened. He finished the presentation, he said, ask questions to him, and he went. Okay. So the point is, if you understand the things, then you become more confident. Okay, you become more confident, you can speak in front of people, you can answer them, you can convince them. In the first lecture, in the first topic, we talked about why public speaking is important, okay, for engineers. And one of the point was that you design, but you have to convince others about your design. Why they should spend money on your design, why they should hire you, okay, and so on. Okay. So this can only happen if you have understanding. Okay, clear or not? So when you understand, you become more confident. Okay, and you can ask the right questions. And it seems easy, right? Why should I understand something to ask questions, right? I am asking questions, right? So my understanding doesn't matter. I can ask anything. No? Why not?
When you ask a question, should be deep and you understand the topic.
No, I'm saying the other way around. I'm saying if you have understanding, then you will be able to ask the right questions. If you have understanding, you will be able to ask the right questions. How? Why? What does questions have to do with my understanding?
Increase.
Huh?
Increase.
No, I'm saying you already have. You are sitting in front of your client. So you are already an engineer. Okay, I'm not talking about the class now. Okay?
See if
Even in
he
class, you don't ask questions, I will be very happy. Yes?
see if he understands the problem, so you can know his knowledge.
Whose knowledge?
You can ask the guy who what's the question?
Your client?
Yeah.
Yeah, okay, and what will happen? Nothing? Yes? Somebody was saying something? No? Yes? Yes?
Well, it's something sense that because if you don't understand what you're talking about, how you can ask a question in the first place. So you need to understand what you are talking about.
Okay. Let me give you an example. For example, the client is talking about using, he is saying that in my building, okay, I want to have a hall which will be like 20 meters tall. The height of the hall will be 20 meters, okay, and from one end to the other end 50 meters, open, okay. I will make a big auditorium, it will be 20 meters high, from here to here 50 meters, okay, okay. See any problem with that? No, right? Because you don't know how to design that hall, right? If you know how to design, then you will know the problems you are going to have. Got it? Okay. You will ask the client then if you want something like this. Auditorium means what? There will be no pillars, right? There will be no columns. You don't want columns and pillars in the middle of the auditorium, right? You want it open, clear. Okay? And in the auditorium you need good sound quality as well, right? You know the echo surround sound, huh? You need the whole thing. Okay? So if you put pillars or beams or something, it will disturb the sound as well. Okay? So if you understand, then you will ask the right questions. Okay? Otherwise you will come back, you will say yes, yes, yes. Yeah, very good. What a dream. I will make this happen. And you will try to do it in the end. You will sign the contract, okay, I will do it, I will give you the design in 1 month. And then you come back and you do and you try to do it and you make mistakes. Either your design will not be good because you don't know how to design, okay, or you will understand later on, oh, I have this problem, I have this problem, I have this problem. So you will understand after 2 weeks. You already lost half of the time of your project. So now you will go to the client for asking questions. You're getting my point? Okay. So the person who knows, who understands, he can see the problems from the start. And he will start asking the right questions from there onwards, instead of waiting for the problem to happen. Got it? Clear? Okay. Another example, because area is traffic, so examples come from there, most of them. So for example, somebody says that we are going to have, we have too much traffic problems on this location. We remove the signal and we put a bridge over there. Okay, putting a bridge over there means you will increase the speed. You will increase the speed of the road, right? Signal you have to stop, so the speed is less. So the bridge, the speed will be full. Okay, and after the bridge, just after that signal, there is another signal. So the people now who were coming slowly from this signal now will come very fast to the next signal. Okay, so they may have problems or accidents for the next signal because they are coming too fast. Clear now? Okay, so when you, again, if you understand the things, then you can ask those questions and you can see those problems from the start. Okay, so this is what I mean by asking the right questions. Okay, so you will not ask the client about what will happen to the next signal. Are you going to change it or not? Okay, or you will not ask this client that in this big auditorium without pillars and without beams, Okay, you need lot of money and you need to put a lot of steel in there. So can you afford it? Okay, so if I don't have the understanding, these type of questions will not come in my mind. Okay. Okay, so what we have discussed up till now, first of all, the role of engineering for the society. The things which we are providing, they are used by general public, and our decisions will affect their safety, the environment, and quality of life. So in engineering, we are trying to solve problems, not just knowing something, but know something to solve a problem. Okay, yeah, the qualities which we should have: responsibility, integrity, judgment, and there was something else which I forgot. So in your studies, we try to develop our understanding so we can make good decisions in life later on, in our careers, in our professions later on. Okay, so you are not just providing solutions, you are providing solutions which others can use, okay, or which have less consequences. Okay, so the problems which normally, when you are going through the courses, the problems which we normally face is we don't see the application of the course. Okay, for example, you are studying mathematics, you are studying maths, and they are showing you how to integrate and differentiate and do this with the log and do with this with the exponential and solve this equation and so on. So in many cases, students don't see where to apply them. Okay, I understand all this, but when I become an engineer, how this will happen? Okay, where will this I use it? Okay, where will I use this one? Okay, this is the first concern. The first problem is you don't see the application of what you are learning in your profession. Okay, so you don't see the link. If I learn this, what will be the effect on my engineering later on? Okay, where will I use these techniques in engineering later on? So this is the first problem. The second problem is your position in the job market. Okay, so I know this, I know this, I know this, but is it enough for the job market? What I know now, the skills I have, the knowledge I have, is it enough for the job market? Okay, so there are two problems, and both of them are linked with the connection of the studies with the profession, the connection of the courses with engineering, with civil engineering. Okay, so in these courses and in the later courses, you should be looking at things from a practical mindset. Or the courses should develop this practical mindset. Okay, so not just learning something, but you should know how to apply it as well. Okay, if you know the equation, the most common question, the most common problem in the exam is what? You gave us this equation, and this is what we know what to do with the equation. That's it. Okay, this is not a practical mindset. Okay, or this is not the test of your understanding. If you understand something, then you can use the same thing in 100 different ways. If you understand something completely, then you can use the same equation and the same thing in 100 different ways. Okay, same as your laptop or your mobile. Okay, somebody must have thought when the mobiles were invented, the phones were invented, these phones were invented. Earlier they used to be just for calling, right? Then somebody thought, okay, we can send messages as well, right? And the same thing. Then somebody else thought that why not use it for more things, right? Okay, so this can only happen if you have a practical mindset. Okay, if you are looking at things, how it can be used more, or where we can apply the principles which we have learned. Okay, so when you are looking at things from a practical mindset, you try to move forward, you try to grow yourself. Okay, so in every course or every task which you are doing right now, You should be looking at it from a practical mindset. Where will this be applied, or where can this be applied? Okay, and don't worry about asking questions. You can ask your instructors, you can ask your teachers, okay, I understand this, but where will I use it? Okay, got it? Clear? Okay, so we have, I asked this question in the last lecture as well. To become an engineer, you have to take some courses before, right? And you take those courses in the first few semesters as well, semester 1, 2, 3. Which courses? Calculus and physics, chemistry, right? Maths and sciences basically. Okay, maths and sciences. So why do we, and this is the most common problem we have with the engineering students, that we don't see the connection of these courses. Okay, if I'm teaching concrete design, steel design, traffic engineering, you see the direct connection, right? Okay, this will affect highway design, this will affect the building, this will affect the column, this will affect materials and so on. Okay, but you don't see the connection of the maths and sciences courses with your profession. Okay, where are they being used? So just to give you some idea, that these courses are basically telling you okay, I'm just writing these things, they are already in the slides, much clearer way, but just for the sake of this. So, these courses are, we said science is the study of the nature, right? In science courses, or in science, or a scientist studies how the nature is working. Okay, so nature is not something which is permanent, which is fixed. Nature is not fixed, right? Things around you are changing constantly, right? The temperature is changing, the wind is changing, the time is changing, the light conditions are changing, the earth is moving, and so on. Okay, so these courses tell you or give you an idea how these systems change, how the things around you, how they are changing. Okay, how they are going from one condition to the other condition. Got it? For example, what are the states of a matter? A matter can be, anything can be what states? Yes? Gas, liquid and solid, right? So how does it go from solid to liquid? You do what? How does something go from solid to liquid? Yes? You heat, right? Okay. So now, and how does it go from liquid to gas? Evaporation happens why? Because it happens. Evaporation happens because heating, right? Okay, heating, or you can apply more pressure on it and so on. Okay, so now you understand these linkages. Okay, so now you can use it. Just give me an example. Okay, I already have something which is in solid state, but I want to use it in liquid state or gas state. The most common example in this region is what? Water. Yes, water is. And another one, water is common all over the world. Common. But was it more important for this region? This region is known for what? This region is known for what? Concrete. Why? Bahrain is famous for concrete. Yes. Bahrain, Saudi. These countries are known for what? Oil. Yes. Aggregate. They should come and ask you. They would know, like, they will be happy. Oh, we are known for concrete, we are known for aggregates. We are the world leaders. Yes. Oil, right? The weather, yes. The weather. Both things are interlinked. Yes. Okay, so a very good example of using these states of matter is the oil industry. Okay, when they do drilling for oil and mining, they get sometimes they get the oil in liquid state, sometimes they get the oil in gaseous state, and so on. Okay, so they work around the whole oil industry works around these three states of matter. Okay, so you need to understand the temperature and pressure which causes the matter to change. Okay, so engineers do not come up with these rules. Engineers do not come up with these systems. Okay, so the sciences courses tell you how matter goes from one state to the other, and many other things. I just gave you one example. Okay, changes of matter, just one example. But imagine everything around. Okay, the light, the temperature, and so on. Okay, so sciences courses or the science tells you how systems change, how natural systems change. Something which is linked with it. Okay, what causes them to change? Okay, what causes our natural system to change? Okay, so for example, you have heard about inertia, right? What is inertia? Yes.
Apply acceleration for a body, then let's take the same place, whether for example in the car, if you are in the car and you accelerate the car, your position it will not change until you you take all the acceleration that's the car applying. It's applied to the car and both of two bodies are having the same acceleration, then the body will move with it.
Science has changed. Isn't it relativity? What do you see?
No, it's inertia.
Inertia. Okay. So, but anyways, I'll check. Maybe I put the word wrong. But what I understood, or what I know, there's something which we say, okay, if a body is moving, okay, if a body is in a state of rest, if the body is in the state of rest, it will remain in the state of rest until you apply some force to it, right? And the body is moving, it will keep on moving until there is enough resistance to slow it down, to stop it, right? Is this what you were saying? That's it? Okay. Okay, so this is inertia. Okay, that if this laptop will not move until some force is applied to it. Okay, and if your car is moving, it will keep on moving until you apply the brakes and so on. Okay, or there is some other resistance which can break the movement. Okay, so now you understand this. So now you can use it for designing cars, for example. Okay, or for designing your supply chains and so on. Okay, the conveyor belt system and so on. Okay, so now you understand how things can move. Okay, inertia tells you why or how things will move, what will cause something to move, or what will cause something to stop. Okay, and then you use it in all of your industries. Okay, in all of your work. Clear? Okay, so how systems change and why they change. Okay, so this is what science tells you. Inertia, the theory of inertia came from science. We didn't do it. We didn't come up with it and so on. Okay, and the last one is what will happen, what will be the results if a change happens. Okay, if something goes from solid to liquid, yeah, that thing is changing from solid to liquid. But what will be the effect around it? Okay, so you have heard about, for example, there are two types of chemical reactions, right? Two types of chemical reactions, right? Exothermic and endothermic, right? What's the difference between them? What's the difference between them? Exothermic chemical reaction and endothermic. Yes. Nobody knows. How did you come here? Yes. No one? Okay, Google it. No problem. Go ahead.
So the elements react to each other.
That's a chemical reaction, but there are two types. These two types. Huh? Exothermic, endothermic. I'm saying it.
They use heat to do the reaction and they give heat in
Yes.
the reaction.
Yes. Therm means heat, right? Therm means heat, temperature. Okay. Exo means heat is going out. Endo means heat is coming in. Okay. When you mix water with cement, you know what type of reaction is it? Heat is coming out or going in. We use cement, right? Where do we use cement? In concrete, right? And we use cement with water, right? Huh? So what type of reaction is it? Exo or endo? Does heat go out or comes in? Go out. It goes out. Okay? So you must have seen that. So I know if I mix cement with water, it will become like liquid. Okay. What will make it become like liquid? Water, right? So I know how things are changing. I know why things are changing, right? The third thing is when they change, what will happen? So when cement mixes with water, what happens? Yeah, it becomes like liquid. Okay. Now you can move it easily. Okay. But what is happening around it? It is now emitting heat. It is causing exothermic reaction. Okay? It is causing exothermic reaction. So after we know this, what do? There's something which we call as curing. We apply water to it. Okay? So when concrete is fresh, we just pour it. When it becomes hard, then after you put water on it or you apply something wet on it. Okay. Why are we doing this? Because of to take care of this reaction. If you don't decrease the heat, the cracks will start appearing in concrete from the start. Got it? Okay. So again, coming from science. Okay. The science told me what is happening, why it is happening, and when it happens, what will happen around it. Okay. So when I know, then I can use it or I can do something about it. Okay. So if I don't know what will happen when cement reacts with water, what is the result? Then all my concrete will start having cracks. It will fade. Got my point? Okay. So just by missing this one small point, you can destroy your entire building. The reason is you didn't put water, you didn't try to decrease the temperature after the cement or after the concrete became hard. You didn't consider the type of reaction. Got it? Clear or not? Any questions? Okay. So the point was the science courses are basically trying to increase this sort of an understanding. So they are not telling you where to use it. This will come after. But what they are telling you, you will use it in engineering. Got it? Okay. So all these things, this is from chemistry. This is from physics and math both. This one and the state of the matter. Okay. So the state of the matter is both chemistry and physics. This one is both physics and maths. Okay. You need equations to calculate the inertia and the force required to move the body and so on. Okay. So all these things are interlinked. That's why you need to take care of these things. Okay. So in calculus, the most common thing which you do is you take derivatives, right? Okay. You are taking derivatives, integration, and differentiation, and so on and so forth. So where do we use derivatives? Okay, or for calculating what do we need derivatives, or where do we use calculus? Okay. Okay, so the equations which you study in calculus and how to take their difference, their derivatives and how to integrate them, these equations can be later on used to calculate some of these parameters. Okay, so loads, building loads, okay, temperature, it could be temperature of the environment, it could be temperature of your specific member and so on and so forth. Flow of water, okay, or flow of oil, okay, which is very important for your pipeline design. Okay, so the equations are coming directly from taking derivatives and taking integrations. Okay, and speed of vehicles, for example. Okay, so speed is a derivative, right? Derivative of what? Tell me. It's a very easy question. Speed is a derivative of what? Acceleration. Acceleration with respect to what? Acceleration. Time.
The distance function.
Yeah. The distance. The derivative of distance. Distance upon time. Distance upon time. Right. So it's very easy, right? Imagine speed, distance upon time. So derivative of distance with respect to time. Okay. So every time you are calculating the speed, you are taking what? A derivative. Every time you calculate the distance upon time, you are using calculus. Got it? Okay. Now imagine how many times you have done it, and how many times you will do it when you will come to me in property. I will hold you again. Clear now? Okay. So every time you are taking a ratio, you are taking derivative. You are using calculus. Okay. So you do this in all these things. Yeah. So with the use of these derivatives and with the use of these equations, you can answer questions like the risk of change. Speed of change. Do I need to control it or not? Okay. So these derivatives, they first of all, for example, if I take derivative of something and it becomes 0. If I take derivative of something and it becomes 0, it means what?
Slope is what slope.
Slope is 0, right? Slope is 0, right? Okay. But what does it mean in terms of change? If the derivative is 0, that means what? No change. Okay? Derivative 0 means no change, right? Clear or not? Okay. If a body is just turning, inertia, it's just turning, and take the derivative of the distance upon time, I will get 0, right? So that means speed is 0. Body doesn't move, right? Okay. So is something changing or not? So how do you know it? When you take the derivative. Okay. Derivative becomes 0, that means no change. Clear? Then at what speed is it changing? This is very obvious, right? If the derivative value is higher, that means the change is very fast. If the derivative value is lower, that means the change is slow, right? Clear? Okay. The correct word is speed. Okay. If speed is higher, that means the change is fast, right? Okay, and so on. Then do I need to control it or not? Okay. So if I need to control it, how do I control it? Okay. So these questions are all related to changes in the system. So change in the system is calculated using derivatives or integrals and so on and so forth. Okay, and all these questions, which are very important for engineering design, they are answered by using calculus basically. Okay, and I gave the example of cement, right? Okay, so when you mix cement with water, there is a reaction. The reaction is generating heat, right? Okay, so if I take the derivative, will I find it 0? There is a change, right? There is a change. Okay, so the derivative will not be 0. Okay, the value will tell me how much heat is being produced. Okay, you have different types of cement. Some of them produce more heat, some of them produce less heat. Okay, so I cannot apply the same method of curing for both types of cements, right? Okay, so my method will change when I know the speed of the heat exchange. Got it? Clear? Okay, and by the way, the problem is the heat exchange is very fast. With cement, the heat exchange is very fast. That's why we need to keep it wet. If it was slow, then it will happen automatically in the environment. If something is generating very low amount of heat, it will automatically dissolve in the environment, no problem. But the heat exchange is very fast. So because it is fast, I need to control it. If I don't control it, I will start seeing cracks. Got it? Okay, so all these things are related to the change and they are coming from the concept of calculus. Okay. Okay, then we have in all the courses, whether they are engineering or maths or even physics, okay, we are using the equation, right? Okay, we are using the equation. What is the meaning of an equation? If I write an equation here, x equals 2y plus 3z plus c square. What is this equation representing? What is this equation telling you? Huh? A rule. Yes, very good. When I heard this, I came here and people were asking me, will you give the rules in the exam? I said, what rules? You bring your card, you bring your pencil and calculator. Okay, but yeah, it's a good rule. Yeah, it's a good word because it comes from Arabic, right? Qanun. No? Yeah, you will translate it. Okay, but anyway, yes, it's a good word. So each equation is giving you a set of rules. If I change y, x will change how much? 2 times, right? Okay, and so on and so forth. Okay, so if you want to change x by 2 times, you have to change y by at least 1 time. Okay, so each equation gives you or it represents a set of rules. Okay, and these rules are connected between 2 different parameters, right? These rules are providing you connection between 2 different parameters, in this case x and y. Okay, so the rule is between these 2 parameters. So how y will change or how x will change when I change y, and so on and so forth. Okay, so each equation is giving you a set of rules. Each equation is telling you what happens to one parameter when you change the other. Got it? So if you understand the equations, you know the rules of the game. You know the rules of your field. Okay, can I do this? I cannot do this. Okay, and so on and so forth. So anyway, so for example, I have an equation. Okay, I use this equation to calculate the length. The length comes out to be negative. Possible? The length is negative. Possible? Not possible. Okay, so these are the set of rules we have. So now you have to understand the equation, and if you do not understand the equation, you get whatever answers you are getting, right? Okay, so don't look at the equation just from the sake of memorizing. Okay, I know the equation. Okay, x means this, y means this. No, what are the rules behind this equation? Okay, how these parameters are connected with it. Okay, and So now if you look at this equation, you see y and z and c, right? Three things. Okay. The effect of y on x, is it linear or quadratic? Huh? Linear. Effect of z, linear. Effect of c, not linear, right? It's not linear. Okay. So these are my assumptions. I'm assuming that y has a linear effect on x. Yes. Y has a linear effect on x, and c has a non-linear effect on x. Okay. So these are what we call as our assumptions. Got it? Why I am saying this? You must have developed this equation using some data. Yes. But on the same data, you can make different types of equations. For the same data, you can make a linear equation, you can make a non-linear equation. It is possible. Okay, and both of them can be acceptable. Both of them can be used. Got it? You may not have done it now, but people do it. Right? Okay, if I give you data between x, y, z, and z, you can make this equation, or you can make some other equation as well. They will be between the same parameters. Okay, but the type will change. Okay, instead of writing 2y, I may write log of y here. I'll get a new equation, right? Okay, and that equation will also will be between x and y. But now the assumption has changed. The type has changed. Okay, so behind each equation there are assumptions. So behind equation there are rules, there are relationships, and behind each equation there are assumptions. Okay, so and yeah, and behind each equation there are limits. Okay, behind each equation there are limits. Okay, so for example, you know this equation? Huh? What is m? What is c?
And must see
Velocity of light, right? Velocity of light. So this equation is only applicable for a specific value of c. Okay, this equation only applies to a specific value of c. If I change it, this equation is no longer applicable. I am talking about some other universe. I am not talking about our universe, right? Okay. So every equation has limits where it can be applied and where it cannot be applied. Got it? Okay. The equation you have to calculate the speed of car may not be applicable to calculate the speed of sun. There, and vice versa. There? Okay. So the equations which you have to calculate the strength of concrete cannot be used to calculate the strength of steel. Okay. Each equation has its own limits. Okay. Now I told you three things about the equation. When you are studying the equations, each equation represents what? What was the first thing? Rules. Okay, and the rules are connections. They are providing you connections between the parameters. Okay. Second thing was what? Huh? What was the second thing? Each equation represents assumptions. Okay. Like I'm asking you again because I didn't hear. You don't have to do the second time. Okay. So each equation represents some set of assumptions. Okay. Mainly which are shown by the type of equation you have. Assumptions are basically the type of equation you have. Okay, and each equation is showing you, or each equation has its own limits. Okay, so memorizing equation is not enough. Okay, knowing x, y, z is not enough. You need to know what are the relationships, what are the rules, what are the assumptions, and what are the limits. Okay, if you don't know them, you will be making mistakes and you will not even know. Okay, you will say, okay, this equation happens very commonly in traffic course. I teach equation for capacity of a highway, okay, and the students they use the same equation to calculate the capacity of a signal intersection junction. Okay, that equation is not applicable. Highway is a highway, right? And the signal is completely different. A junction is completely different. Okay, so when you don't understand the relationships and the limits, you will, even knowing the equation will not work for you. You will know the equation, but you will not apply it properly. Okay. So in many courses you go for labs. I don't know which one. So in which courses you go to the labs?
Physics and chemistry.
Physics and chemistry only. We don't take you to labs at all. No?
Materials.
Materials. Okay. What else? Construction, surveying. Okay. So what are you studying in the labs? What do you do in the labs? Apply what?
What we study.
What you study. Oh, somebody didn't study, they will not go to the labs, right? Yeah. Anything else? What do you learn from the labs? So you apply, you already learned, now you're applying, right? But what are you learning new in the lab?
We have the practical part of the
Like what?
So for example, we now study investigate how does we mix concrete.
Yes.
That's the theory part. Now we go apply it in the lab.
So
So we learn the practical part. That's
you learn the practical part. Okay. I'll just extend it. It means that you will learn when you do something with your hands. Okay. When you do something with your hands, what are the errors which can happen? Okay. And how can you minimize them? This is the whole part of doing it. The whole concept of putting you in the labs. Okay. Or making you do some things with your own hands. Okay. You already learned what happens if I do this. You can read it in the book. Okay. Or somebody, your teacher can tell you face to face in the class, if you do this, then this will happen. Okay. And what he is telling you is coming from lot of data. People have done it in all the countries of the world. They are getting the same answer. They are getting the same results. So it's not like you will go to the lab and find something new. Okay. But what we are looking for when we do this, what are the errors? What are the problems which can happen? And how we can minimize them. Got it? Okay. So in surveying, Dr. Nizal keeps on telling me there is a theory of errors, right? Random errors, systematic errors, right? Okay. So you can hear about it, but until you go and use the instrument yourself, you will not know how they are happening. Okay. And what should I actually do to minimize them? Okay. So until you go and mix concrete yourself, you will not know how the problem can happen. Like there in concrete there is a problem. Sometimes the aggregates are heavy, right? And the water and cement are light. So sometimes what happens, the aggregates are at the bottom, all of them. And the light material is on the top. Okay. So why it is happening? Then you go and see. And how can I not make this happen? You will learn about this. Okay. So I know, from theory I know, when I have concrete, I should mix it properly. Okay. And this type of mixing and this type of compaction and so on. Okay. But until I go and do it myself, I will not know that what are the effects of not mixing well, or what are the effects of not compacting well. Clear? Okay. So basically in the labs, you are trying to see why results can change, what are the errors which can change the results, and how you can control them. Okay. In fact, when you are going in the labs, what you are looking for is already known. What you are looking for is already known. Okay. We used to do titration in chemistry. I don't know what you guys do it or not. They mix acid with base or something and changes colors and so on. Anyway, so they would say that, okay, if you are doing it for this substance, then your value should be this much ml. The value is already known. If somebody, they tell me the value should be 10 ml, and I come, no, I got 50 ml. They will give me an F. They will go, okay, go home. You failed. Okay? So, same applies to engineering labs as well. What you are doing, if you say this is something new, they will say, what did you do? You made a mistake. It should not be new. Should be same as what we are already telling you. Got it? Okay? So, when you go in engineering labs, you are trying to see how we can, when we go in real life, when we go on construction sites, what are the problems which can happen and how we can minimize them. Okay, so in each course, basically you are trying to improve your thinking. You are trying to improve your understanding. Okay, not just memorizing text and memorizing equations and so on and so forth. So you are trying to do two things. First of all, your decision making, and the two most important skills you are trying to develop through all these courses. Okay, your decision making improves when you understand things. Okay, when you understand things, then your decisions are much better because you know what can go wrong, how will it go wrong, and how can I control it. Okay, and your analytical skills will let you deal with new data, new systems. So when you are taking a course for the first time, it's all new data, right? You are looking at the lectures for the first time. You are looking at the equations for the first time. Some of you look at the equation in the exam for the first time, right? From where did it come from? One of the students wrote last time in an exam, I am shocked that you gave this. The only student in the class who wrote this. Everybody else was happy. He wrote to me in the question paper, I am shocked to see this question in the exam. So, you get the point. So, every course is new data. So, when you get new data, what do you do with it? Okay, so to improve your analytical skills. Okay. Okay, but so there are two. So we are talking about similarities, right? How your courses are applied to real life. Okay, but there are things which are, when you get into real life, professional life, things become more serious. Okay, if you make a mistake in the exam, what will happen? You will lose marks, right? Okay, or if you maybe you lose enough marks, you get an F and you do it again, right? So there's a chance to correct it. Even if you don't correct it, the loss is only in terms of your grade, which we don't even care about, right? Like I'm talking about V. We don't even care about it. Okay? So the result is very low. Okay, the result is only to yourselves. Okay? You will drive us mad, that's another effect, but controlled, the result is controlled. Okay, but if you make the same mistake in real life, okay, so you are designing a building for your project, you made a mistake, you got bad marks in the project, maybe they will ask you to do it again, that's it. But if you made the same mistake in real life, you may cause somebody a loss of life, you may cause somebody a loss of money. and so on and so forth. Okay, so and you may get into court issues, they may ban your license, they may put you in jail and so on. Got it? Okay, so it's like when you're driving a car, so your instructor has a control, right? The instructor who is with you, if he stops talking on the phone, then he has a control. Okay, he can actually stop the car. Okay, so exams are like this. But somebody who got the license, now he's on the field. He is driving his own car, no instructor. He makes a mistake, he will go and hit somebody, right? Okay, until he was with the instructor, he was safe. So your classes are like you are with the instructor. Okay, you may not get the license because you are making too many mistakes. But if you not make mistake, you do not make any mistake during your test, but now you are making mistakes in real life, you will cause a lot more problems and to others. Got it? Okay. So we will continue with this next time as well.